Hi everyone, today what we're doing is we're going to use a table to graph our quadratic, our parabolas, okay? So we're using tables. Oh, come on, pen, there you go. Using tables. Now tables are helpful to us because it keeps things organized. So let's look at an example of this. If I say y is equal to x squared, okay? And we did this in our last lesson. What does x squared look like? And as we develop our understanding of what these graphs look like, we can go through our very basic way of saying, hey, as long as I just plug in a bunch of x values in here, we can figure out what the y values are. If x is 0, what's your y value? If x is 1, what's your y value? If x is 2, what's your y value? But you can see that me just writing in numbers isn't organized, is not helpful to a point where it might actually causing more time trying to organize it. So we come up with something called a table. Often this is called a t-table because we're going to look at looks like a T. That looks terrible. Let's make this straight. And on the left side, we usually put our variable that we're plugging in, and the right side is our output. You can think of this again as your input and your output. I'm inputting an X, I'm outputting a Y. This is our input, and this is our output. Input and output. Well, let's see what input do we want to plug in. So it's nice to put things in order. They don't always have to be in order, but again, we're trying to stay organized here. So I'm gonna actually start off with 0 right in the middle here. Now, the reason why I put 0 in the middle, because I'm gonna give you a -1 and -2 on the left, and give you a 1 and 2 on the right. So usually I put 0 right in the middle. Now, is it always gonna be 0? In this simple case, yes. But as our equations get more difficult, we could shift that parabola left and right, up and down. And we'll see that this becomes hard to use to figure out where the middle of my graph is. Okay? It becomes harder to use. Okay, so what am I really doing here? I'm just telling you on the left side what values I'm choosing to plug in. And let's go ahead and plug it in as an example. Here we go. So if I say x squared, remember this is x squared. I'm going to plug in x squared. Now x is now 0. And 0 squared is 0. Plug in 1. 1 squared is 1. 2 squared is 2 times 2 is 4. So we have our input of 0, our output of 0. Let's go ahead and graph that. So if x is 1, 2, -1, -2, going up 1, 2, 3, 4, -1, 2, 3, 4. So you can see that I'm just creating a simple table, and then I'm also doing a simple x and y chart here. So all these skills we've developed over the last year. So let's go ahead and plot our first point. If x is 0, y is 0. I'll put a dot at 0, 0. Our next dot is if x is 1, our output is 1. 1, 1. Our next dot. If x is 2, y is 4, right? 2 squared is 4. That's the output. Now, these points are points on the graph here. And we're going to draw a curve. Now, why am I curving it? Why does that look like a line to you? It kind of does, right? These 3 points, if you squint really hard, they look like a line. But let me go ahead and show you using a ruler here that they actually don't connect. These two don't connect. And if I drew another line over here, see, so it's not really one fluid line. And it's not made up of 2 lines. It's actually a curved parabola. Now try your best to draw a little curve here. Okay. Now what happens on the left? Let's do the same. We're going to plug in numbers. We're going to plug in -1. So we have -1 squared. What's negative times a negative? Let's see if you remember what that is. Negative times negative. And -2 times -2 is +4 and +1. Thank you very much. Now again, these give us a ordered pair. An ordered pair is an x and y value. Order matters, -1 and 1. and negative 2 and 4. Now, you might hopefully notice that we actually repeat y values, 4 and 4, 1 and 1. See, these values are being mirrored over from one side to the other. Oops, I'm cutting off. Oh no. Give me a sec. So we have 5 points here. 1, 2, 1, 2, 3, 4, 5. And could there be more points? Yeah, there's actually infinitely many set of points. As many points as you want to graph, we can graph. It just takes us more work. And let's go and graph the new points that we came up. Negative 1, negative 1, positive 1 over here. And then negative 2, positive 4. And you end up with this U shape. Again, look at the left 3 points. They look like a line, don't they? Don't they look like a line? But I'm going to show you using my ruler here that they actually are not in a line. See, I totally missed that third point. I totally miss the other point, right? So these aren't a line. It's actually going to be a curved surface for us. Okay, and that's a parabola. So this is our most easiest, right? This is when I say easiest, I mean like the amount of mental thought needed to. We just plug in numbers and we just cross our fingers that it comes up to be a nice graph. Now, for us, it was super helpful that I knew where the center was, right? We knew where the middle point. And we've also called this middle point the axis of symmetry. Meaning, at x equals to 0, this is where the left side looks like the right. Right? It's like a mirror reflection here, where the left side looks like the right. These points are all the same distance apart, right? Okay. So if you know where the middle of the graph is, great, you're gonna have this nice graph. But let's do another one here. And again, this is the problem that we did before. Y is equal to x squared plus 6x plus 8 equal, okay? So let's try this one. And we're gonna do the exact same thing. We're gonna plug in 0 and a bunch of numbers that we find that we think are easy. We're gonna plug in our x and y's. And let's start off with 0 right in the middle, just like we did before, right? Just like what we did before, let's start with the 0 right in the middle. Now this problem is a lot more difficult. Y is equal to x squared plus 6x plus 8. But the skill of me just plugging in numbers is not gonna change. So I'm gonna say 0 squared, x is now 0, plus 6 times 0, plus 8, okay? And this is just practicing your math skills now. 0 squared is 0, 0, 6 times 0 is 0, plus 8 is 8. All right, okay, so if I plug in 0, we end up with 8. Let's go ahead and graph this on the side. When x is 0, y is 8, okay? When x is 0, here's 0, 1, 2, 3, 4, 5, 6, 7, 8. My goodness, that was a lot of work, okay? I go 1, 2, 3, 4, 5, 6, 7, 8. Now, this is why a lot of people want line paper. It makes your life a little bit easier. Is it necessary? I actually never use line paper. I just try to draw my graphs as best as I can. Line paper actually, for some reason, in my brain confuses me. There's too many lines now. Okay. All right, so we have 1 point. Let's come up with another point. Let's plug in 1. 1 squared plus 6 times 1 plus 8. Now, hopefully you caught what I did here. Every time I have an x, that's when I'm going to plug in my new x here. So x squared means I'm going to write 1 squared plus 6 times x means 6 times 1 plus 8. We'll do the math. 1 squared is 1, 6 times 1 is 6, plus 8 is 7 plus 8 is 15. Do you want to graph 15? Do you guys want me to graph 15 way up here? Nope, I don't want to do it. Okay, so that point is really far away. So that's actually, we'll go not to 2, because if I went to 2, we'd be even far, we're blowing up here. Looks like this graph is going to take off to the moon, and I don't want to do that. Instead, let's go the other direction now. Let's go to -1 and see what it looks like at -1. Then we'll do -2. and then -3, and then -4. Seems like a lot of work. Meh. Let's say let's just go and do it. -1 squared plus 6 times -1 plus 8. I want you guys to please do not overthink what I'm doing. What I'm doing is I'm just copying the x value into my function, my equation, my formula. And with that, I'm able to get my y value. So it's almost like asking someone their phone number. Where you ask them the phone number, they're going to give you a bunch of numbers. Right? And if you ask someone else their phone number, they can give you a bunch of numbers too. So if I ask -1 for its phone number, it's going to tell me -1 squared is 1 minus 6 plus 8. And this gives me -5, 3. Oh, hey, I can graph 3. 3 is something that's kind of on my page already. So let's go ahead and do that. -1 and 3. If I ask -1, what's your y value? It's going to tell me 3 by plugging it in. So -1 is on my left, and 3 is right here. 3 spaces up. Okay. All right, let's go ahead and do -2. -2 squared. I want you guys to try doing this. See if you guys can beat me. And if you can get the answer before I do, go ahead and type in the chat. So -2 squared, -2, and then 6 times -2, and then plus 8. Hopefully you can get that as -2 squared is 4 minus 12 plus 8. See, this is kind of tedious, right? But it's not anything that's very difficult, right? Washing the dishes is not difficult, right? But it's just tedious. Okay, 4 minus 8, and 4 minus 12 is -8. Oh my gosh. This is 0. Wow, we hit a 0. And -2, we're at 0. Okay. -2, we're at 0. Let's go to -3 squared plus 6 times -3 plus 8. Now, if you get a problem like this on your test and you're asked to write out the table, thank you for the answer. If I don't see this work here, I can't give you credit, right? So -3 squared is 9. 6 times 3 is 18 minus 18 plus 8. 9 minus 18 is -9. -9 plus 8 is -1. Turns out, oh, that's -1. Okay. Right, -1 here. Let's do -4. I'm running out of space here, but I'm going to squeeze it in there anyways. -4 squared plus 6 times -4 plus 8. Let's see, what do we get here? 4 squared is 16 minus 24 plus 8. Turns out 16 minus 24 is -8. -8 plus 8 is 0. Oh my goodness, we found the other 0. And I ran out of space, so you know what? I'm just gonna write it on the bottom, -5. Here we go. So you could always continue the table on top or on bottom. So I plug in -5 squared plus 6 times -5 plus 8. -5 times 5 is 25. 6 times 5 is 30, so -30 plus 8. That's going to be -5 plus 8 is 3. Whoa, wait, I've seen 3 before. I've seen 3 before. So it looks like I am just going to start copying this -5, I'm sorry. I'm starting to repeat my numbers. Why? Because this parabola is going to have a mirror image from the left side to the right side. And our parabola here, I can go ahead and finish up my drawing. Shoots off to the moon. Shoots off to the moon. Now, will we have to do this for every parabola? And the answer is, if you want to do things the hard way, yeah. If you want to do things the hard way, you can do this for every problem. But in algebra, our goal is not to crush it like this every single time. Our goal is to find a pattern and then learn from that pattern how to draw things faster. Let me give you an example back to when we're looking at graphing lines. I asked you to graph y is equal to 3x plus 2. Okay. We learned that there are characteristics about this equation. Y is equal to mx plus b. And if you remember the characteristics, Right? Remember the characteristics, you could graph this in less than 10 seconds. B is 2 and M is 3. B is the y-intercept and M is my slope. And slope is made up of two separate words of rise over run, which is 3 over 1, because it's just the number 3 with an invisible 1. Oh, there's no noise every single time I talk. Okay, so we looked at this line equation, and if you knew the characteristics, you knew that the y-intercept is where we start, and you know that slope is how we change, you can graph this as y-intercept is 2, put a dot, and the slope is 3. So from this one point I was given, I can go count 1, 2, 3 over 1, and we have our line. Let me go ahead and get my ruler here. My ruler. Now, was that really that hard when you drew that line? Hopefully not. It's something that we did a long time ago and you might have forgotten it. But we could also have done the table version of it, where we say, hey, what is it at 0? What is it at 1? If it's at 0, 3 times 0 plus 2, and 3 times 1 plus 2. 3 times 0 is 0, 0 plus 2 is 2. 3 times 1 is 3, 3 plus 2 is 5. And guess what? At 1, this is 1, 2, 3, 4, 5 spaces up. This is the same point as whether I use a chart or whether I use the characteristics of our line equation. So if I know the characteristics, I can draw it a lot faster, and I see the growth is just a 3. I don't have to do every single one of these values. For parabolas, that's actually what we're going to do also too. This is a great way to start. This is just our opening, right? Our opening ideas. Right? This is just our starting to get into parabolas. What do they look like and why do they look like that? But as we see in our next lesson, we'll be able to graph this whole thing. We're going to be able to graph this in 30 seconds. And I'm not kidding about that. Okay? We'll be able to graph this in 30 seconds because we're not going to say, hey, what is it at every one single point? But we can find the characteristics of the graph and then graph it based on its characteristics. All right, we're going to do the table one more time so you guys are kind of on the same page. And then that's going to be your Excel. I'm going to have a couple of you guys stay behind for my breakout room. But besides that, you guys can get started on the work a little earlier today. But let's give you guys another question. X squared. Oh, just real quick, right here. For this problem, could I factor it? What two numbers multiplied become 8 that add up to 6? I always use this one. 1, 8, or 2 and 4. Hopefully you see 2 and 4. X, 2 and 4. Plus, plus. Now, here's something kind of cool. What values will make this go to 0? -2 and -4. You already have two answers. -2 and -4. So we could actually graph our parabola using 2 points. We could say, hey, oh, darn it, other way around. -2, -4. Parabola. Okay. And so that's, again, another method. And we're going to be talking about that. That's another one of those advanced techniques that we're talking about. Save a lot of time. Okay. Okay, let's do another one. X squared. Let's do minus x minus 6. Okay. That's our graph. And then we're going to create a table for it and then graph it. X and y. We're going to use some numbers. Let's use 0. And we're going to say 1, 2, and -1, -2. Okay. And let's see if this was anywhere near the middle of the graph. Again, this is the problem with us just using tables. If we have no hint of where to start, it's like trying to look for your car keys and you don't remember where you left them, or your cell phone and you forgot when's the last time you used it. You guys ever feel like that? Oh man, I left my cell phone someplace. Where's the last time I used it? And you had no clue. So guess what? You gotta start everywhere. So let's start with 0. 0 squared minus 0 minus 6. 0 minus 0 minus 6 is just negative 6. Oh gosh, that looks terrible. Let's plug in another value. Plug in 1. 1 squared minus 1 minus 6. 1 minus 1 is 0. And we're left with negative 6 again? Really? Let's do 2. 2 squared is 4. 2 squared minus 2 minus 6. 4 minus 2 is 2. 2 minus 4 is negative 4. Over here, negative 1 squared minus negative 1 minus 6. That's 1 plus 1 cancels out. No. 1 plus 1 is 2. And then 2 minus 6 is negative 4. Hey, look, we're starting to repeat. Look, do you guys see how we're repeating here? At negative 2 squared minus negative 2 minus 6 is 4 plus 4 is 8, and we're left with 2. 8 minus 6 is 2. All right, see, this is just grinding out the numbers. We're back to literally like 3rd grade math here. So now let's go ahead and plot these points on a graph and see what this parabola kind of looks like. And you would agree with me, hopefully, that this is a lot of work. This is really just a lot of work. And there's also a lot of risk involved because I don't know if I'm going to get anywhere near the center of that parabola. Right? It really is just a lot of work. And the goal of us in algebra is not to think, like not to work our butts to death, but to think harder and come up with solutions that would save us time because we're not worried about the numbers, we're worried about the pattern. And math is all about patterns. Okay, here we go. So we have at 0, we're negative 6. 1, 2, 3, 4, 5, 6. That's negative 6. At 1, positive 1, we are at negative 6 also. At positive 2, we are at negative 4. 1, 2, 3, 4. That's like right here. At negative 1, on the other side, probably a little too far away, we are at negative 4 also. And at negative 2, we are at positive 2. Wow, you really got. Okay. Now, if you look at the pattern, we have negative 6, negative 4, negative 4. What do you think the next value at positive 3 would be without doing any other work? Could you say that's just going to be a mirror image at 2? So we have our parabola going on. And it's going to be a dip right in the middle. All right, so we're able to come up with the parabola. We're able to find all the points. It's just grinding out. It's like me asking 6 people. Imagine if your family had 6 people in it, and you had to ask each and every one what they want for dinner, right? Or where do they want to go to for vacation. And you know, so many family members, it takes a lot to get an answer from them. But if you had a pattern that you had already, this year we're doing this, next year we're doing this, year after that we're doing this, every summer we always go to the beach. Guess what? I don't need to ask every family member. Our pattern is we're going to go to the beach. And our goal as mathematicians is find out what that pattern is. Okay? All right. That's it.